I'm going to talk to you today about how we've developed a special kind of mouth guard that is going to hopefully save lives. And oh, sorry. There we go. Okay.
Other side, Richard.
Other side. Okay. Oh, yeah, it's better, isn't it?
There we go.
No, I'm still. Yeah, okay. So, yeah, well, firstly, I work for Keytree, so we're about 400 people. We're an award-winning company that really specializes in digital transformation. So we do a lot of commercial projects. We do like to do data for good projects as well, and we've worked on a few, but on this one, we're proud partners of TIBCO on the One Step Forward, so I was glad that got a name check up front. So I'm going to talk to you today about how we're gathering data real time in rugby, and I should actually go way back here and make sure I name check the sponsors. So we don't develop this, we don't sell this product. This is sold by a company called Sports and Wellbeing Analytics based in Wales, and they call this PROTECHT. We've been working for them, developing the hardware and developing the software behind it, working a lot with Swansea University, who have been doing a lot of the research into the actual maths behind how you translate accelerometer data into risk of injury. So get back to where I was now. So PROTECHT, real-time monitoring of head impacts. Now, I always like a prop when I'm talking, so I brought along a mouth guard. Don't put it in your mouth. This has been in horrible places. So, yeah, but please feel free to admire the design and the sheer beauty of the electronics. And this is the bit. I spent 25 years designing silicon chips. I'm way more interested in this than that. So please pass this around. I'll just explain what you should look for, so otherwise you'll just get a green thing in your hand. So, right, this bit, this little circular bit over here, that's the battery charger. Actually, some of it's labeled up there. This bit, if you're feeling really adventurous, you can hold it up to the light and see a little sinusoid. That's actually the aerial. Sorry, is this only interesting me? It's a good chance it could be. That's the battery, they're boring. You can see two tiny little chips down here. They're the important, that's the gubbins. That is the linear acceleration, X, Y, and Z. And it's also the rotational acceleration, bang, head moving around, okay? So yeah, that's what to look for. Have a little look at that and pass it round. So, label diagram up there, all what I just said. So what are we doing? Close coupled acceleration sensors. Well, close coupled in this case means actually clipping into the mouth. Prior to this, there were various techniques used to try and assess head impacts on things like American football. There'd be pitch side cameras, there'd be other techniques, just trying to work out just how hard somebody had been hit. But there's nothing to replace actually connecting to the skull through your teeth, effectively. And then we beam that to pitch side analytics, and we can do all kinds of cool stuff once we start to get data. So we can start to tie it into the player history. We can start to figure out, how many bangs on the head has this particular guy or lady, actually I'll get to that, really interesting facts about women who play rugby, taken this season. Or this lifetime, this playing lifetime, and gives you the pitch side staff, the medical staff, instant feedback on exactly what's going on and if somebody should be brought off if they've had a dangerous impact. And also it'll stop the French just claiming they've got a knee injury and calling it a head impact, which I don't know who follows rugby, but that is just bloody outrageous. But it'll add up to, longer careers. A player gets to play for, 15, 20 years max. And higher performing teams, but people will be healthier after rugby. There have been some horrendous stories, deaths even, from people getting the wrong kind of bang on the head. I did my name check up front. It's been a cast of thousands, but we've been very much in the middle of helping design this. My slides are unashamedly, a lot of them are stolen, so there's a little prize at the end for how many asterisks you can catch, but these are all stolen from Dr. Liz Williams, who's leading the research effort at Swansea University into a lot of the science behind just how you model what a smack on the head means for the brain going wonky. I use a lot of technical terms like wonky, I hope I don't lose you. So what is concussion? So concussion, well, intuitively you think, well, concussion is just when you get banged on the head. You know, it's not that serious, is it? But it actually is. So you know, there's millions just in the USA where a lot of the research is done. Just in the USA, there are millions of impacts reported annually, and a lot of them are just missed. You know, it says 50% there. There's a later statistic where, you know, it's even higher than that are missed. Secondary impact, that's something that maybe people don't know about. In fact, I've noticed a lot of activity in the press lately about head impacts. There's a lot of stuff about soccer, and some schools are saying they're going to stop kids playing soccer. But you know, I think it's a bit of concussion's character building, so you know, I'm not entirely in favour of that. But secondary impacts, you know, this is where you've been banged on the head once, boom. You know, that's maybe not so serious, but the brain starts to swell a little bit. But then you get banged on the head from another direction. The brain starts to swell there. That pushes on the front one, and then you start to get squeezed. You get squeezed from both sides. That can be fatal. That kills 4 to 6 people under the age of 18 every year. Now, I've had 3 beers. Chronic traumatic encephalopathy. Who was the lady was that you telling me you could speak Greek? I can't remember who, somebody. Oh, right, okay. It's a big word, and I do like using it, but only when I can talk straight. Anyway, that's when effectively you're getting repeat concussions year after year, week after week, game after game. And so that can cause long-term damage. And this is the interesting statistic. This blew me away when I heard about it. So think about it. Think about little toddlers at nursery. Think about the boys, think about the girls. And before you call me sexist, they've done these experiments on apes as well, and apes act pretty much the same thing. But little boys, I've got a boy and a girl. My son spent his career at nursery pushing other people over, getting pushed over, falling all the time, arms going out all the time, learning how to fall. My daughter, far more sedate, generally, you know, following the social stereotype, but barely ever falling over. Now, when they grow up and they want to play rugby, they want to play contact sports, what that translates into, and they can show this time and again, and remember, this is told to me by Liz Williams. So she was saying when girls get an impact, they fall totally differently to men. They pretty much face plant. Now, what that means is, no, it's serious. It's serious because it really causes totally different injuries and way more serious in women than in men. And you know, that face planting actually means they don't break their fall as they're going. There's no subconscious response to throw arms out as much. I'm not saying it never happens, but it doesn't happen as much. And so the statistics for women falling over and women getting head injuries are way higher than men. And the other thing is, the other card that is against ladies who fall over is that they've done some very recent studies to find out that the neurons in the female brain are actually thinner than the male neurons, so they snap more easily. So when you do fall over and when you do stretch those neurons, it can have a bigger impact. So this is another important use for the mouthguard. So who wants to see a brain being splattered? I've got to walk over here to do this because I didn't get my AV sorted out. But right, watch out for the red areas. And so the thing we're looking for here is, firstly, you're all data scientists, so you've got huge brains. So, they're screaming to get out. You're really tightly packed inside the skull. And so you've got surrounded by cerebral spinal fluid. And it's really mushy. I don't know if anybody's been for a monkey brain masala on Brick Lane. It's really soft and squidgy. It's not nice stuff. It's a thing, really. Look it up. Yeah, I was too squeamish to eat it. But anyway, get back to this. So if I click go on this, you'll see as the head goes over, watch out for the red bit. See that red bit right in the middle? It's right in the middle. It's where the two halves of the brain join. So this is where the damage is happening. This is where 50% stretch is happening. And that 50% stretch is a lot of snap as well. So there is brain damage happening in this simulation. So you don't, this is what we're trying to measure. This is what we're trying to bring players off before bad stuff happens. And move on to the next. So this is back to my so what thing. So you know, it's not just a bang on the head. Concussion is serious. You know, we've all seen interviews with boxers who, you know, have trouble forming sentences. You know, dementia, depression. I think another thing that blew me away, and I wouldn't believe it if there wasn't citation back to, you know, this is another slide stolen from Liz, if there wasn't a citation back to a proper study, 3 times higher risk of suicide after a first concussion. Just, yeah. And 6 times more likely to have another concussion, so remember what I said about secondary concussion. All these statistics, anyway, I won't read them all to you, but it's serious and it's worth preventing. So what have we built? I don't know where that mouthguard is, but yeah, I do want it back because it's Tom's and he's gonna give me a concussion if I don't bring it back to him. So inside that mouthguard, there's a gyro, there's a processor, there's a radio unit. So all of this is being put inside that mouthguard, and these are all specially formulated. So each one is specifically measured for a rugby player. And the rugby player gets it molded exactly to their mouth. So there's a really tight coupling to their teeth. So as accelerations are being recorded, then we're really confident. You know, it's not just the mouthguard rattling around. And then that's beamed over to an edge device. So this is what the medics are looking at on the side of the pitch. And then we've got the long-term storage in the cloud. So we want to track players over the history of their engagement with the game. Just so that we can keep an eye on them and do the statistics behind how many concussions they've had, or how, you know, what's the cumulative impact of playing the sport. In terms of architecture, you don't stand a chance of reading this, but anyway, in-mouth sensors going into the head impact application, which is basically a ton of tables inside storing X, Y, Z accelerations, rotational accelerations, bunch of calculations which I will go into in a follow-on slide, so don't worry if you can't see it. And then that gets up-leveled into something that the medics can actually see and intuitively use fairly easily on the side of the pitch. So another video moment. So who wants to see somebody fall over? Yeah, of course we do. So this is something we actually did in the lab, and this is serious because you know, one of the hard parts in this application is gathering enough data. You know, we can't just go onto a public database and just download a bazillion head impacts. We've got to make our own. We've got to start to build our own databases. So this started from a lab experiment. I'm guessing this was probably Swansea Uni. And yeah, this is somebody, 3, 2, 1, and whack, you know. And so he's got a mouthguard in, and we're recording that. We have to do that again and again and again and again and again with different players, not always the same player. So you know, we've got to record that data and start to make sense of, you know, the accelerometer data. So, and this is, oh God, I've got another video moment, so I'm going to get my step count up today. So this is the kind of data that we get. So we get a linear acceleration. So that was one of those tiny sensors. That's measuring X, Y, Z. That's the front, back, side to side, up, down. Sorry, I'm patronizing you. You know what X, Y, and Z is, so apologies for that. But then we have an overall level of impact, and that's linear acceleration is important for one kind of snapping. And then the rotational acceleration, also recorded in exquisite detail. And then we also monitor a lot of games. So one of the sponsors you'll have seen maybe at the front was Ospreys rugby team. Not having a great season this year, but maybe they're taking a lot of head impact, so I'm not overly disappointed. But if you watch this video, you can see these guys, the interesting stuff happens right at the end. Actually, if I hit pause, I can zoom over there. So you kind of see one of the guys coming in, and where is he? Come on, you beauty. There we go. This guy over on the left with the 3 stripes on his boot. He's just waiting, and then he's got these accelerometers in his mouth. And you can see he's tackling, and he gets whacked, and he falls to the ground, rolls away. Now, like all good rugby players, he pretty much shrugs it off, gets up and goes and tackles again. There he is, rolling out from underneath, looking where the ball is and jumping straight up and just running back in. God, I love this game. Yeah, and that's the real world data gathering. So I said, you know, data gathering, we don't just do it in the lab, we do it on the pitch as well. And we're hopefully at the stage where it's just starting to roll out to a lot of the tier 1, tier 2 rugby teams. So we're going to start to get a whole mass of data. Let me get rid of this and go back to slide land. Oh, my button's not working. How do I make it work? Oh no. That was the last video, so I don't really mind. I can just use my button here. Right, so yeah, it's back again. So from data to useful information then, so we get the tackle in. That goes into the accelerometer data, pitch side analysis. This is the peak impacts, peak linear, peak rotational, that's what PLA stand for, and the seasonal injuries gathered, actually not just seasonal, also over the career of the rugby player. And then up-leveled into an anonymized data set that will indicate how many impacts, what's the average linear, what's the average rotational. And before you think, well, what kind of use is that to a medic? Well, it is fairly well mapped. Well, I say fairly well, it's a developing field. One of the other challenges, so I've talked about data gathering, one of the other challenges is because there's been a lack of data, then the science is rapidly moving, rapidly advancing, and so we're really trying to keep up with and develop the science here. And you know, Swansea University have been all over this, and this is all public information. The way that it's done inside the accelerometers is a bit IP bearing, so I can't talk too much detail about that, but I'll talk a bit about what's around here. So there's the Wayne State tolerance curve. Before you get too engaged in that, the small print at the end is it's not particularly great for brain damage, but it's a starting point. And so then there's the GAD severity index. You can get all of this on Wikipedia. But that is a simplified version of that, and it also simplified is important for real time. If you've got to simplify calculations, do them fast. And so we can start to see then that we've got some form of measuring the acceleration and the duration of the acceleration and working out when a player is in danger and when they're maybe safe. So we can start to form a judgment as to whether they should come off, whether they, or how many more head impacts they can sustain. And so we developed then this head injury criterion and head impact telemetry severity profile. So that's where we start to add up the total impact. But it turns out, interestingly, that it's the rotational stuff that's the dangerous stuff. I mean, the linear is pretty dangerous too, don't get me wrong, but the rotational stuff is, is turning out to be very important when we're assessing head impact. So there's differing opinion. That's really what this hysteresis curve is showing. So, we've got one opinion here coming from Pellman et al. Way back in 2003, a later study here that's showing in terms of how fast your head is snapping round to the probability of an injury. So that's another thing that we can map inside the tooling that we're developing. And start to map it into something that's a recommendation for looking after the player. I mentioned a lot of the stuff is coming from American football. American football, they say, is willingness to be injured. I'm not entirely sure that's right, but maybe it is. But we're going to hopefully get lots more rugby data coming through. And this was my first point, that the rotational acceleration is actually very important. So we're using a lot of very fast-moving, very in-development research to map that to something that's a real-world recommendation. So this is my last slide. So really, where do we go from here? Well, there's a ton of places. There's, firstly, we can start to build better player databases. We can build virtual players. We can build virtual models of professional players so that we can start to work out, well, it's not just about the head impacts they've taken. It's training. It's other lifestyle things they might have. Some of them might be heavy drinkers. I've heard that happens in rugby sometimes. Some of them, they have all kinds of environmental stuff going on around them. And there's, we can start to, so that's the player backgrounds. And we can start to then understand how that affects the severity of concussions and the impact of concussions. And there are just a ton of other games. When you think about it, just head impacts happen all over the place. Got particularly nasty photos that I managed to pull out here from field hockey, ice hockey, soccer, Aussie rules stuff, which I don't pretend to understand, but it looks rough. So yeah, there's a ton of exciting places we can take this. This is a product we're actively working with SWA on. And yeah, if, I don't know where you come from or what you do, but if any of you are interested in that, at the very least you can go into PROTECHT, spelled wonkily, or go onto the SWA website. And the other thing is, I work for Keytree. I'm heading up the data science team, and I'm actively recruiting. So if any of what I've talked about, we don't just do this, we do boring commercial stuff as well. In fact, if I'm honest, we mostly do boring commercial stuff, and we do, this interesting stuff too, but actually I find the boring commercial stuff quite interesting too. So please, I know that not everybody wants to spend 10 hours preparing the perfect email. Just drop me an email and say hi. Really, it can just be simple as hi, because I don't have a job spec yet. I'm actively, January was supposed to be me developing a lot of job specs, so just say hi to me on email. Don't LinkedIn to me, because I never read those. And I'll get back in touch with anybody who says hi later on in the coming months.